everybody. My name is Kyle, and today we're going to be talking about Redisearch. First, let me introduce myself. I am the head of developer advocacy here at Redis Labs, and I've been using Redis for a long time, and I've been using Redisearch since its inception. I've been there through the whole process of it being developed, and a lot of these topics are things that were not originally available when we did maybe a Redis University course or some of our initial information about it. So this is going to be pretty new stuff for a lot of people, but it is important things that make Redisearch really great. So the one thing I will say is this is not an introduction, so do keep that in mind. In this case, we are going to be actually just going ahead and doing everything, assuming that you know a lot already. So keep that in mind. If you haven't used this, go back and do another intro training on Redisearch, and then you'll be ready for this one. We'll do it in approximately 3 sections. We'll talk about some documents and patterns that you might want to use and how you add documents and manipulate those. We'll go into a particular use case called ephemeral search. And then the third part, we'll talk about aggregations. So let's just go ahead and dive in right now on document patterns and usage. So initially, it was very easy to add documents to Redisearch. There was very few options. But as the uses of Redisearch started to evolve, as did the ways that you can add documents to Redisearch. The first thing to look at is a couple different things. In FT add, you have the option called replace. This is an upsert, so we'll talk a little bit more about what that means in a moment. But basically, add and replace, and then we'll get to replace partial in a second, finds all existing entries in the index for that given document. So in this case, when I talk about entries, I'm talking about individual terms that are matched in that document. Now, it's going to remove all those existing entries when you do replace, which makes a lot of sense, right? And then it's going to add new index entries in its place. You can kind of think about this as an ft-del, so delete, and then followed by ft-add with your non-indexed fields. Now, the thing to keep in mind about this is ft-add and ft-del are not exactly how it's happening on the inside of the search engine, but it's a pretty close approximation and use. The other thing to keep in mind is ft-del here does not have that dd, which is document delete option on it. So this is the best way to conceptualize this. If you're not familiar with ft-del dd, ft-del dd will delete the document that's underlying it. And this has some implications, which we'll get to a little bit later. So moving on to ft-add replace partial, this only finds the specified index fields and then removes those entries. So if you are looking at a particular field and you want to replace that, it's going to leave the rest of the document intact, right? So this is the key difference here. So think if you have 5 fields and you want to replace partial with one of those. That will keep the other 4 fields in their existing state, and then the one field that you're doing will find all the index entries for that, remove those, and replace it with the next one. So this enables you to do a couple different things, right? This enables you to do small kind of in-place updates to your documents and keep the index really up to date. So let's take a look at this. We're going to walk through each individual part, and then we'll discuss them. So moving forward, let's talk a little about ft-add replace and its upsert behavior. So first thing we're going to do, we're going to use ft-get, and we're going to look for the document named instructor. It's going to return nil. We know at this point that that document doesn't exist. So let's add it. This is the information we want to add to it. We have our doc ID instructor. Our doc score is 1. We have first name, last name, and age, and those are all indexed fields in text and numeric. And then we have country, which is a non-indexed field that we're adding along to that document. This is the syntax here, ft-add my people, name of our index, instructor, our document ID, then our document score of 1. We're doing replace here. This comes before the fields demarcation line, because remember, fields will put you basically in a mode where it's going to expect the field and followed by the value, field followed by the value, on and on and on. So you can't really have any options after fields in ft-add. So it's going to result in the document being indexed. And if we get that, it's going to return it back with everything that we expect it to. And if we do a search for it, it's also going to do the same thing. So we're searching for 39, between 39, and then it's going to return the document as we expect. Replace partial has almost identical behavior. Let's just look at it to be complete. Replace partial, we're doing this ft get, the same way we did before. We have the same exact values and the same exact schema. Replace partial is only different in that instead of replace, we have replace partial. There's two reserved words there. And then we're going to get the value, and it's going to work exactly the same in this particular use case. So keep in mind, this is only when we're looking at a replace or replace partial over a document that doesn't yet exist. So this is, upsert is a portmanteau of update and insert. So this is the insert part of that. Now, let's look at the underlying field behavior when you're doing an update with replace. This is very different. And this is something that we probably should talk about where you want to use this and where you don't want to use this. I think for a lot of people, they see replace, and that's exactly what they want, and then replace partial seems like something more specialized, but actually the inverse is true. Most of the time you want replace partial. So we have all the same things. We have first name, our first, last, age, country, and the country is non-indexed. We have our doc ID of instructor and our doc score of 1. So we do an FT search before age 39 to 39, and we see that this is reflecting in the search index. So it would return all the fields. I've just truncated it for the individual screen that we have here to display all the behavior. How we do this is using FT add replace. And here we're going to replace the first and last field with Loris and Crow instead of Kyle and Davis. Loris Crow is another person on our developer advocacy team. So in that case, we're just replacing these names. And then we result in something quite curious. So the doc ID, of course, remains the same. Doc score remains the same because those are exactly what we had before. But if you take a look at this, you have your first and last, which we specified explicitly in the FT add. Those have been updated. The age, however, was not specified explicitly, and that is sitting there at 39 still. However, it is not indexed. So remember when I talked about how replace is effectively an ftdel followed by an ftadd, and we didn't have that document delete function there. What's happening here is that the underlying hash object, which is actually where Redisearch is storing all of these fields and values, still is retaining age. So age is still in that. So when you do the search, it's not actually indexed on this document, despite the fact that it's actually in the schema. So this is a really specific behavior, and it's unexpected to most people. So where would you use replace? Replace is really used where you're completely overwriting all the fields that are specified in the schema, or it's there for compatibility reasons. I believe replace existed quite a bit before replace partial, but for the most part, many people want replace partial. The only time that you don't want this is, say, replace would be really good if you had, your original document had two fields defined. So imagine that I didn't have age defined here, and I'm doing replace. I'm just doing the first and last name, and then I just want to keep it that way. So in that case, you're not getting this kind of existent but not indexed part of the document. So moving on, let's look at replace partial, which is actually probably what you're more expecting when you're doing a replacement. So here, we have our same document, first, last, age, and country. And then we're going to search for it. We're returning the value back as we would expect. We do replace partial. We're updating Loris and Crow just like we were in the previous example. And in this case, what's happening is we are only updating those fields and age is remaining indexed. So that means it's still findable when we run the FT search age 39 to 39. So it's a very important distinction to keep in mind that this is probably what you're looking for when you're really wanting to update a document in Redisearch. Just keep it in mind, there is still uses for replace, and certainly if you have your code and it's working, you can keep replace in there. But for most people, this is more conceptually what people are thinking about. Um, so replace and replace partial is no create behavior. This is another behavior that we have that's the same for both replace and replace partial in this case, but it's actually quite useful. In this, what we're going to do is we're going to avoid creating a document. So this makes it a pure update operation instead of an upsert operation. So just to prove that we don't have this particular document, ft get my people instructor, that's our doc ID, it's returning nil, so that doesn't exist yet. Now, I'm going to do ft add my people instructor 1, so we have that kind of stuff out of the way. Replace no create fields first Kyle. So what's this doing here? So if we do already have instructor as a document, then we are going to replace the field first with Kyle, right? Whatever that value might be. In this case, that doesn't exist, so we're going to get an error back. Document does not exist. Replace and replace partial will behave exactly the same here. So that's not necessarily a thing, but for the most part, you're probably going to be using replace partial as much as you're going to be using replace, if not more. Now, what's the situation here when we want to update just a document score? In this case, we're going to do something pretty interesting. Let's say we have this document we've been using before. We have this doc score of 1. But fact scores are kind of underutilized in Redisearch, and but they're really useful for really changing how documents are returned and in what order. And you can do things, for example, in an e-commerce application, maybe you want to change your featured items, or maybe you want to change something else that is affecting how those documents are being returned, and you want to do that quite dynamically. Redisearch enables you to do that pretty easily. So we have that same document we've been using over and over again in our examples. What we're going to do here is we're going to do ft add my people instructor, just as we normally would, but we're going to change that doc score from 1 to 0.5. Now, we're going to do a replace partial. Very important, this is replace partial. And then we're going to specify fields and nothing else. So let's reason about this for a moment. What's going to happen here? Redisearch is going to do basically an upsert behavior here, right? So in this case, if you know that this exists, it's going to go ahead and replace it with anything that you specify after fields. There's nothing there. So the only thing it's going to actually replace is the given value here. So in this case, it's going to replace a doc score of 1 with a doc score of 0.5. So now we have done this and we've changed the doc score without having to do any re-indexing. And in Redisearch, the re-indexing is not very expensive, but it's among the most expensive things that the database, actually, excuse me, the module actually does. So the thing to understand about this is just updating the doc score becomes very light and something you can do quite rapidly. This also works if you specify after fields the non-indexed fields. So in this case, you have your information that you're primarily finding finding documents with, and those are all in your schema. And then you have a number of other metadata fields that you want to update pretty consistently. You can do this replace partial fields and then update the non-indexed fields, and there's not a big penalty there. So you can do this quite rapidly and update those very frequently without having to worry about the weight or the performance therein. Um, Now, the other thing that people tend to think about is I want to update a specific document only if something is like this already. Now, I think when I've talked to people about this, they've often said, oh, this is like a where in SQL, and there's a big difference there, and we'll explore that in a minute. So this is truly an if. So we have our same document we've been using as an example over and over again. In this case, I'm going to replace partial if the first name is equal to Kyle. Now, the thing to keep in mind here, and we'll get to this later in this training, is that it has a FT aggregate compatible expression here. So that means that it is just like you're going to use FT aggregate. So if the first name is equal to Kyle in the document instructor, that's very important, then change the first name to Loris. So how is this different than a where? We're specifying an individual instructor, right? So we can't replace all instances where the first name is Kyle, just that one specific one. And then we'll see this updated, and no longer is this first name Kyle. Now the first name is Loris. It is possible to replace, but you probably don't want that. Again, this is something that replace would be kind of odd on, especially if you start considering the ramifications in this particular example. You would lose your last name, your age, indexes along with that. So replace partial is probably what you want. Now, something to shift gears a bit is talking about how Redisearch is working with multilingual indexes. Um, Now, to give a little bit of reminder on this, the schema does not necessarily specify a language. You can specify things in phonetic stuff, but you can't specify a language and with regards to how it's going to stem and do some of the more important features. So you can specify it on the search side and on the document side. So you would use language and you'd specify the language when you're FT adding it before your fields. Now, let's look at this and how it works in practice. Um, there's an important thing you have to keep in mind about this, which is language matching. Let's take a look. So we're going to do FT search language French, right? And we're going to look for oui, French for yes, assuming this is not in the stop words. Now, let's say that in this entire index, we have languages, or indexes, documents in the index for German, English, and French. So multilingual index here. When we're going to do this, the search is going to apply the stemmer and effectively trying to match the French stemmer for any document in a given language. So in this case, it is going to go, okay, does we with a French stem match this German document? But the search is not aware of the document settings of the language. So it's going to do the same things for English and for French. On the other end, when we're adding the documents, this is what we're talking about today, um, we're adding the documents and it's actually going to start stemming things given the language that you specify. So in a German document, you're going to specify we in German, and it's going to take that and say, okay, from the German language's rules, what is the best way to come to the stem? And it's probably going to be different than English and French. Okay, so what this results in is a mismatch. You're not going to actually be able to find this. So if you're searching for FT search language French, we on a German document, it's not going to work because they'll be how it's coming in is different than how it's being searched for. The same for English. And this for French, of course, you're going to match these. Now, how do you handle this? The way you appropriately handle this is by actually going and specifying at a document level some sort of way of filtering by language. So as an example, you might have a tag field that specifies that this is a German document. And then you stemmed it with the German document when adding it, so using our example on the screen. And then in your search, when you're putting your search terms together, you would then put in that it's a German document as well, and then you would have a corresponding language German piece into this, so you'll be able to actually find them. And from a perspective of like, what do you start out with? Of course, Redisearch it has a default of English, so it will automatically assume it's stemming in English. So if you don't manipulate the language at all, it's probably not going to find very good stems, but at least it will operate consistently. So keep that in mind. Okay, now it's time for an exercise. The way this works is you're going to go ahead, I'm going to read to you and explain this a little bit further. You're going to pause the video after my explanation. You're going to do the exercise, and then we'll go over the results. So first up in this explanation of the exercise, I want you to create the index we've been using before. If you're going directly from Redisearch 101 or the intro course, then this will be very similar. So FT create my people with a schema of first, last, and age using the appropriate field types. So adding your own name with your own age and a doc score of 1. So add an exclamation point to your name after adding the document. So you have the document added. Now you will need to do an update to that. How are you going to do that? And then the next step is to change it back to your original one. So, for example, in the third step, I changed my name from Kyle to Kyle exclamation point. Now, in the fourth step here, what I want you to do is do a conditional update. So if something in the document is what you expect it to be, then update that name back to it. So there's a couple options there, and we'll go over that when we do that. So go ahead, pause the video here, and I'll let you work on it. Okay, I hope that wasn't too hard. Basically, what we're going to go over is the entire steps. This is how I did it exactly on my machine. So we created our index. We talked to you about that verbatim, so that shouldn't be that challenging. But now we'll look at the adding the document in here. We just add it in a pretty standard way. So no options here. Then what we're going to do is we're going to do replace partial on this. So I basically said me is my document name. Just whatever the original field of first is, just change it to Kyle exclamation point. Now, the more complicated piece here is when we're doing a conditional update. We're using replace partial again. And then from my example here, what I did was went to the last name, found it by the last name, and then updated it to just Kyle, which you could, of course, put in Kyle exclamation point or your name exclamation point and be able to do the same thing. All right, moving forward, let's go ahead and talk about Redisearch and what's happening in the future. The timing on this was a little bit in the middle of things. By the time we had to record this, Redisearch 2.0 is not out, and it will be out soon. I don't have a date at this point, but it does bring some changes to the entire way that we add documents. So if you've already seen this in our intro course, this will be a review. For those of you who didn't do the intro course, it's worth saying. So documents and hashes have become kind of the same thing. So you're able to manipulate documents just with hashes in themselves. So they have the same properties that you might expect. You have expiry, TTL, delete, etc. Anything that you would be normally doing with it, you can do that. And you would be able to manipulate those hashes with just a set like you normally would. But how Redisearch knows to index it is by defining rules. So let's take a look at this and we'll go into a little more detail. First up, you define the rule. This is just saying, here's how I want to index something, and hold tight on how we do that. I'm going to get to the whole explanation and then come back to that. Here we're adding a document, and it's as simple as an H set. We have our first part is the key, and that becomes the doc ID, and then we have the fields and values, which become the fields and the values in the document in Redisearch. If it matches the rule, then we're going to do something, but if not, we're going to ignore it. But if it does match it, we're going to index that data. So it's possible that you enter a hash and it's not indexed sometimes, and then other times it is based on the rules that you've defined. Later on, when you're querying that data, what's going to happen is it's going to work just like you normally did. It's just going to return the hash object as opposed to returning the actual document as you were used to. So it's going to be able to return both the fields and values just the same. Now, rules. Creating the rules are kind of interesting. There's a number of different ways you can create the rules. You name your rules first. So this example is my rule. That's the name of that rule. Prefix. So this is going to look for keys that start with user colon. Okay. So in this case, it does match the example that we have on screen. Another way it can match is with a particular field. So if it has the field ID, any updates to those hash objects would then be tracked by Redisearch. And then finally, you can set up actually a value-based expression. So, for example, if the birthday is related to 85, and the expression that you're putting here, then it would be tracked or not tracked. So this is what's coming, and it'll be really interesting when that happens because it does really fundamentally change how you can do this and the transparency at which you can do it. Okay, shifting gears, let's talk about ephemeral indexing. Ephemeral indexing is an interesting pattern that is supported by a very small feature in Redisearch that makes very big differences to your actual application. So let's kind of look at what you would normally do in this case. So think of a purchase history on an e-commerce site. User 1234 asks, what items did I purchase in the last 12 months? What's going to happen is it's going to go to a table. It's going to have all purchases, that's the table name, and then it's going to sort through those through some indexing mechanism and find the ones that match the user ID and then return those back to them. The problem with this is going to have millions and millions of rows in it. And when you want to try to do something like full text searching on millions of rows, it becomes quite slow, and there's all sorts of things. But the big deal here is that you're actually keeping a lot of documents in there that are totally irrelevant to the question that's being asked. So it's asking about user 1234, but all these other users, 456, 8901, 2345, 5, these are all irrelevant to the question that is being asked at this moment. So the way you fix this and the way you can do this, and this is not unique to Redisearch, is you can do what's called a compartmentalized index. Asking the same question, basically you know a deterministic way of matching it to a particular index that you have. So you're going to look and index all purchases user 1234, which is a small subset of the whole of all the purchases, right? So it can be very small, and that user is only looking in his or her own index. Now, what happens when user 456 comes along? They are going to go ahead and looking in their specialized index. Now, this is something that wouldn't work very well in a lot of databases or search engines because there may be some weight to creating indexes, or um, there might be a lot of metadata inherent to those indexes. So when you start doing this, you end up with a lot of things that are extra, right? This doesn't make a lot of sense if you just keep these around forever. You're better off just using a generalized index instead of a compartmentalized index. So um, let's think about this in a different way. First thing first, let's think about two different things you can have. You can have a storage of record and then an operational index. And those do two different things. So looking at the life cycle and kind of flow of something that might work this way. We have our user 1234 that we've gotten to know quite well. When that user logs into the service, um, a couple of things happen. Asynchronously, we get all the purchases that user has ever done from um, your storage of record. Um, and at that point, you take the storage of record information and then you start indexing it in Redisearch. So we have these two different storage engines, right? Storage of record, which is a persistent, um, durable database that doesn't really have to be performant because it's doing something very kind of simple here. It is taking and dumping out all that user's purchases as an example. It's going to create a temporary index in Redisearch. Now this is occurring asynchronously, so at that point your welcome page can be viewed, and human scale interaction times are pretty small, are pretty large rather, in comparison to the compute times, which are quite small. So a user may sit on a page for a couple seconds, which is an eternity to a computer, but a pretty normal amount of time for a human being. At that point, let's say a user actually wants to look at their purchase history, which is going to occur some number of seconds probably after the user logs in. At that point, you can go and reference that purchase history from a Redis search or the operational index as needed, and pull that data as immediately. Now, you're not really doing anything with the storage of record here. That is sitting in the background and it's not doing anything right now. And you can do full text search on this, which is really quite cool. So you can see really specific things in the index. Um, then later, a user purchases an item, and you need to do some updates. This is a very familiar kind of caching type pattern. At that point, basically the item purchased is gone to the storage of record first. And once it's committed to the storage of record, then you commit it to the operational index. So very similar to how you might update something in some sort of cache. Um, but the important thing is that that update is happening to both, right? Um, let's say the user walks away, they are then timed out. So their session times out, and at that point, um, you don't need to keep the operational index around any longer because they need to relog in, or there's another step that comes in to repopulate that index. So Redisearch can automatically set up that timer, and the timer is based on any interaction point. So either searching or adding or doing any type of operation like that. Um, After the point which they haven't done it for n amount of seconds, then the entire document index goes away. So the documents and everything else, just the memory is released, making room for more people to do this. So what's really cool about it is that it's simple to implement. Creating an ephemeral index is very simple. So the first thing you do is you use Redisearch to create, instead of creating one single index, you create many indexes that are based on, let's say the user in this case, but per compartmentalization. Users is one case, but you could also do some time slicing and some other interesting patterns here. The only real difference here is in this temporary option on the FT create. This creates an index that lasts for only 60 seconds. And that's the only thing that's different because FT search and FT add, they remain the same. Now I should note here, this is only available in Redisearch 1.6 or higher. So if you try to do it in 1.4, you're going to get an error if you put in the temporary bit. Okay, Now, it's time to go do another exercise. So it's your turn to do some ephemeral indexing. So go ahead and flush your database between these exercises because we're going to be creating something a little bit different. We're going to create our index we've used before, but with one difference. We're going to put that temporary reserved word before the schema, and we're going to set it for about 15 seconds. You can set it for whatever your comfort level is. 15 seconds is a good amount of time. You can get a couple commands in, but um, you could set it to 30 or 60 seconds if you feel like you're a little slower on the uptake here. So you add a document with your name and age, as we've done previously. You run ft-search to find yourself. You should be able to find yourself at this point. You wait some amount of time, about 15 seconds. And after that 15 seconds, um, you should run ft-search again and see what happens. Now, I will say about 15 seconds or a little more than 15 seconds here because, again, you do a stopwatch or a timer, it's probably not exactly 15 seconds which it's removed. There is some wiggle room there that the database does to not cause any kind of crazy um, pauses when everything might the temporary indexes might all expire at one time. So pause the video here. We'll return to this, and then we can go over it. All right, let's go over it. So here we have what I did to do this. I did my creation here, and again, I split it on 2 lines here. Yours is probably not going to look like that, but this is just for clarity, so you guys can see it quite well. So I've created my people. We have our schema, first, last, and age. Return OK on that. Next up, we're going to add this, and this is the bog standard same stuff that we've done over and over again. So no difference there. We're going to search for Kyle, and that's going to return that document as we would expect. Now I waited about 15 seconds later, and at this point, when I returned that value, returned and said ft-search my people Kyle, which worked 15 seconds ago, it now says there's no such index. So super useful, especially as the pattern of like purchase history search or something along those lines. Really, really useful. Shifting gears a little bit, let's talk about aggregations. Now, aggregations in Redisearch have been around for a while, and they allow you to do some things that are not possible in any other way. And it can be a pretty intimidating feature of Redisearch. If you use aggregations in other databases, we're a little bit more explicit in how we specify it. So it's not just something that kind of slides in. So for those of you who haven't really done aggregations before, they basically process multiple rows and then transform them in one way or the other. This can basically result in many rows being reduced to a smaller number of rows very often, or it can result in those rows changing in some way. So it uses the same query language as search. But there's a distinction here that there's also an expression language, which is different. They share some things, but they are distinct. So do understand the difference. Um, and then you can apply transformations, group things, and sort them. This follows a pipeline of these actions. So there is no specified order here. This is just an example that we put together. So for example, you might filter group things, and every group has at least one reduce, apply a transformation, sort them, and then apply another transformation. And after that, you could apply a filter again and group again. So these are composable. So there is no sequence in which you must do them in, and there's no requirement to do all of them. So let's take a look at just an introduction overall to the syntax. It's going to look a lot like search, ft-search, up to a point. So ft aggregate my index for a truck. This is an example I've used previously where we're looking for like used cars, right? So this would find documents that contain both Ford and truck. Now, we have a number of different features that we add in. We have load, which we'll get into each of these individually a little bit later. Group by and reduce, sort by, apply, and limit, filter. Now, as I mentioned previously, these are all things that can be done 0 to as many times as you want. So you may have some aggregations that don't do any limiting and other ones that do limiting 5 or 6 times. So keep that in mind. Now, excuse me. The next thing that we need to talk about is a particular syntax quirk that Redisearch has. It is sometimes used in other parts of Redisearch, but it's really prominent in the expression language. I should say in the expression commands. So we call them count prefixed parameter properties. That's a lot of P's, C, P, 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 but it's a pretty easy concept. And it's here really to ease um, the parsing of the queries and the not necessarily the queries of the arguments that come in here, and it makes it very explicit what's happening. So there is no does this is it there's no ambiguity. Does this belong to this? Not belong to something else? You get used to writing these, but it's a little unnatural at first. So you'll have a parameter or an argument that you're putting into the ft aggregate command, and you have a number of properties that go along with that parameter or argument. Um, what you have to do is specify the number of properties which you're using, because that can be variadic, right? They can mean different things depending on what you're wanting to do. So in this case, I'm saying my parameter 3. This is a prefix, right? So we're doing this before, not a postfix. Um, and then we're specifying the number of properties that are associated with the parameter. So in this case, prop, 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 they're all associated with the parameter. If it was 2 here, the thing that's parsing the command that's coming in to Redisearch would say, okay, that last prop is something different. So keep in mind when you see this, you'll see it over and over again, and sometimes you'll even see a 0 there, that this actually means quite a bit. Okay, the first thing to know is that you will probably look at a schema, and then to make it really optimized for aggregations, you have to do a couple of steps. You certainly can do a schema that was not built for this, but there's a couple of things you want to do if you're going to do aggregations more than a few ad hoc times. So we have our standard, aggregation schema that we'll be using through this course. This is not an aggregations-friendly schema just yet. What we're going to do in it is add sortable to a number of different fields. Now, the thing to understand is that this doesn't work for tag or geospatial fields. So sortable is only compatible with text or numeric fields. Okay. So the other option here is for fields that you didn't mark as sortable, to make them available for aggregations, you need to load them. So right here, I'm loading the field here that wasn't marked as sortable. Otherwise, if you don't do this load step, it will be completely, Redisearch will not be able to find anything on that given field. Okay. Now, sortable, it does come at a cost. It does have a little bit of memory requirements and storage requirements, but it is something that you would want to do because the performance will be much higher. If you're using load, it's basically an ON operation for every document in the index. So in that case, if you have a million documents, it's going to have to visit every single one of them, and it will be excruciatingly slow. Sortable, however, provides a shortcut so it knows exactly what fields are where, and it's kind of provided that ahead of time. So you're exchanging any type of extra storage that you'd need for a computational benefit later. And it's just not very good performance. That's why it gets that thumbs down. Okay, so for the next part of this exercise, we're going to go step by step through a relatively lengthy aggregation pipeline, and then we'll look at it all in one big thing. The thing to understand here before we get into aggregations is, as you start looking at aggregations, the command length or the what you're sending to Redis becomes very, very large, and it starts to look unlike Redis if you are only used to seeing things with like get and set in Redis. So it really does give you the power of a lot of things, but you do have to specify things in your commands. And one thing I will caution you to as well is just to understand that you're sending so much more to Redis. So as a consequence, even if you're sending a bunch of aggregation commands that are very, very large, the tendency is for just the transmit time to feel a lot longer, even though it may just be a millisecond or so longer, because you're not getting and sending 12 characters worth, you're sending 100 characters worth. So think of that, just be mindful of this, that it's going to do that. And then even when you're writing your applications in your client libraries, you may see a difference in how you have to do that from a source code standpoint. So you're going to have to get to some different strategies there. So first thing we're going to look at is we have this index here. We have the field my field, and right now we just have 1, 2, 3, 4, and 4. And this is a text field here. We have marked it sortable, so do understand that. So the first thing we want to do is group by. This will take something and we'll group up logical parts of this. So we're grouping by my field, right? And then we're seeing that prefix property notation that we were talking about before. We're saying group by 1, and that's my field next. Um, Now, what's going to happen here is kind of interesting. We're going to take this, and it's actually going to generate, well, first thing we have to do is do a reduction. We specify the reduction. Group by always has to have at least one reduction to it. We're going to reduce by count 0. What's a 0 doing there? The 0 is actually our number of properties that are coming after it. We have 0 properties here, so we just say count 0, and it's going to move on, and it's going to interpret the next thing as another part of the actual command. And then we're going to say as fcount. Now, what does as do here? As will create a pseudo field for the purposes of returning those values and for manipulating them in the composable pipeline. So let's take a look at this. So what I've done here is taken my field, we're grouping that, so it's going to take those individual fields, excuse me, documents and group those together by those field values. So we're reducing it by a count here, and then we're putting it into fcount pseudo field. So notice that 4 was repeated once on, or it's repeated twice here, and everything else was just a single value for each number. So this is coming back in with my field. So we have all the distinct values represented here, but we have fcount, which is actually telling me how many times that's happened. So as an example, 2 is only 1 time, so that gets a 1. 4 is there 2 times, 1 is there 1 time, and 3 is there 1 time as well. So we've really changed this. We've added a column to it and we reduced the number of documents that are in this pipeline. So we went from 5 to 4. Now, Redis has a number of reducers that are available. I won't go into specific detail on all of these. Go ahead over to redisearch.io and take a look. I'm using count here, but there's also count distinct, which is slightly different, and count distinct-ish, which is one of my favorite API namings in a while. And that's basically where you're exchanging accuracy for performance. And then you have your other ones. Many of these deal with numbers. So we're got the sum, min, max, average, standard deviation, quantile, that sort of thing. Those are all dealing with numbers. And we have some other ones as well where you're talking about random sampling or the first value. Okay, so now we've done one part of this. So we've already done quite a bit. This is longer than your average Redis command. Let's move on to doing a little bit more. Now we're going to take and do some sorting here. So we're going to sort by 2. Why 2? It means we have 2 properties after it. And then we're going to use the at field notation. Now, the application of the at field notation is consistent, but it seems inconsistent when you start looking at it. On screen here, you see as fcount and then at fcount. The difference here is as fcount is basically specifying a string that has not yet become a pseudo field or a field. And then sort by is actually that pseudo field or field that we're referring to. And then we're doing it in descending order. So we have ASC and DSC, DESC to specify the sort order. So this was along the one side of the screen here, we have what was already the values. And then we're going to go ahead and sort those. So now by the fcount values, we have sorted it in descending order. So let's take a look now at some more. So we got sort by already done. Let's apply an expression. Expressions can be really, really powerful in Redis search aggregations. So what I've done, immediately after that sort by, we're applying this, and inside the quotes here is our expression language. So I'm going to upper my field, so we're using at field notation here. So it's referring to a field or pseudo field as my field. Now, a question you might get here is, why do we need as my field here? This is because if you leave this off, it will create a new pseudo field named upper parentheses at my field in parentheses. We don't need that. That's not necessary. It certainly wouldn't hurt anything, but it's not necessary. So what I'm going to do is use and specify my field, and that's going to replace the existing true field with this pseudo field. So how does this look? So we've done this, and we've gone from having the lowercase representation of those characters to the uppercase representation of those characters, quite simply. And you notice that the sort order has been retained as well because we're doing the sort order earlier in the pipeline. Like I said, the expression language is very, very powerful and quite extensive. There's three basic kind of categories here. You have time and date manipulations, where you can specify a Unix timestamp and put those into it and get hour, month, day, that sort of thing, and format them in various ways. So this is one of the only places that really understands time in a real way in Redis. So those are pretty straightforward. And then we have arithmetic. And these are basically different things you'd use only with the number type. Or you can actually use literals as well. So you could get, for some reason, if you wanted to get the absolute value of -12, you could do that. But you usually are putting the at field location into a numeric field for these. And then you have string manipulation ones, like our upper and lower, substring, formatting things, matching terms. So you could, again, go to redisearch.io and take a look at all these different options that you have. Of course, you also have the standard kind of arithmetic expressions, or excuse me, operators, so plus, minus, divide, all that stuff are available as well. And then you can do the kind of binary ones that we saw earlier, where we were kind of looking at the rules that we're applying that uses that expression syntax as well. So let's go ahead and filter. Now, filter is something that's kind of weird. People get confused by filter a little bit. Filter is applied in the pipeline, and it is distinct from the term matching that you're doing in the query. So the query can only work on documents, and the filtering can work on the documents that are put into the pipeline and the fields and pseudo fields that it's generating. So we had as my field, and then we're going to filter that using this comparison logic in the expression language. So fcount, and then we're looking for things that are less than 2. And that will return back this, eliminating one of the documents or the rows. You can think of it either as rows or documents, because at this point it's not really a document any longer. But it's for consistency's sake, you may want to think of them as documents. So now we've eliminated that for my field and with the fcount too, and it has filtered those. Now filtering does have to go through and look at all the different things in the result set, so it is not as performant as kind of the term matching that you do in the actual document query. Now we're going to go ahead and do some more sorting to it. Now this is not strictly necessary, so some people may look at me and go, Kyle, this is kind of repetitive, but I do want to show you this because it does indicate what you can do with Redisearch. So here I'm using sort by 2. We have that kind of variadic number of properties here. So we're going to say sort by at my field in ascending order this time. So it's going to take the current state of the pipeline and then do a sort on that. Okay. And now, if you take a look at all of this, we can then limit those results. And limit works pretty similar to how you would expect it to work in SQL. I think that is one of the interesting parts of SQL that does deserve to be moved forward in time, is how limit works. It's very makes a lot of sense to most people. So in this case, we're limiting 2. So we're going to the second entry, and then we're going to get 1 value out of it. So it's only going to do a 1 count. So as you can see, we've done a lot of things. A lot of things have moved off the screen. So let's take a look at it all together. So ft aggregate is our command. We're using the index here. The one thing I didn't show earlier is actually that we're using a star here. The star basically means I want to look at every single document. You don't use that so much in something like just standard search, but it's more common in aggregations that you might want to do a star. But you could easily put in terms here. So for example, if you were thinking back to our, used car example, then you might want to say, at make equals forward or something, or at make colon forward, or whatever that might be that you need. And then then the same pipeline could be applied, right? So when you're entering this in, this will probably be on one line that will kind of wrap around at least twice in your terminal. So it looks quite different than what you would expect it to look like. But to review, basically what we're doing here is we've taken my field, and then we have taken all these values, and then we have applied the group by, sorted it, or done a group by, sorted it, applied the expression, we filtered it, we sorted it again, and then we've limited it. And that will bring those 5 documents that were originally generated by the star and result in one final document that looks nothing like the original one. So the applications are pretty extensive for this. Um, a lot of people are using Redisearch for kind of basic search things, but you can do a very powerful search pipeline in Redisearch quite easily. Okay, so now it's time for an exercise on aggregations. Um, as always, we're going to flush the database because we're going to be using the same kind of schema that we've done before, but this time it's going to be a little bit different. Here we're going to create a schema with one field, a color, and the name of the index will be rainbow. Then you're going to add documents, and these documents are going to be 5 documents of the different colors that you want to say. So you would just say ft add rainbow, a unique document ID. That's something you need to do, a doc score, some fields here, and the only field you're going to be doing is color, and that maybe is red. Now, the other thing to keep in mind is that we want to make things sortable in our schema. So do keep that in mind, that will affect your ability to do the aggregation later on. Add your documents in, add 5 different colors here, and that they can be anything, but repeat a few of those colors at least more than one time. And then finally, you're going to run your aggregation over all the records. And remember that the star will give you all records. So pause here for a moment, do this exercise, and we'll be right back. Okay, let's keep going. Okay, here we're going to do our review of the aggregations. And first thing first, we need to create our schema. And the key thing here is that the color field had to be sortable. That's a real key part to making aggregations work for you. Then we're going to add all of our different documents. And I just use doc IDs of C1 through C8 here. Red, yellow, green, blue, purple, purple, blue, 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 right? And then we're going to do a aggregation here. The aggregation is going to be actually aggregate rainbow star group by color. And we're grouping by color, so that's going to give us a count of how many colors on each one of these. We're going to reduce count by 0 as color count, so that's basically adding a pseudo field here. And then we are sorting by the color count in descending order, and we're going to limit it to 1, 1, right? So in this case, it's going to limit 1, 1, and we're going to get like a value back out of it. So you can see we've done all of this in a pipeline. So you can play with this and you limit 0 to limit all the different values that you want to do to get different values out of it. So this gives you an idea of what those aggregations are going to look like. Okay, well that's all we have today. If you have questions, come to our question and answer session, our live Q&A. But let's stay in touch. My name is Kyle. You can find me on GitHub, on Twitter at the same thing on the screen here, or email me, Kyle at Redis Labs. All right, thanks.